back, guys. So today we'll be talking about geometric series. We'll actually be trying out some questions. We'll be trying out geometric series involving simultaneous equations because that sometimes gives students a little bit of a problem. Hope you guys like it. What is a geometric series? A geometric series is derived from a geometric sequence, where we said a geometric sequence has a common ratio, right? It means that whenever you divide the second from the first, or you divide any consecutive numbers, right, you would always get a common ratio. Okay, and that is a geometric sequence. With a geometric series, it involves the sum of this geometric sequence. That's all. We're just replacing the commas between with addition in every single one of them. The formulas for a geometric series is this one over here and this one over here. The differences between these two is we usually favor to use this one when r is greater than 1, your common ratio is greater than 1, and we use this one when your common ratio is less than 1. But it doesn't really matter, to be honest, because even if you swap it around, you will still get the same answer. The reason why the question here says you have 3 over 4 plus 3 over 2 plus 3 ... plus 96. Now this is your series. Now the first thing you need to do is to figure out what your a is, what your r is, and what your n is. Now because we have addition signs, we know we're going to deal with sum. So you want us what's the sum of this entire sequence. So I know from here that my a is 3 over 4. I could calculate my r by dividing the t2 by the t1, which will give me my r. When you divide it, it will give you 2. Your n is unknown because we're not given anywhere in our question, and our Sn, which we're trying to get, is also unknown. So for us to be able to get our Sn, we need to first of all figure out what our n is. And the only way we can figure that out is by focusing on this 96, right? So we're going to say that this 96, we get the number of terms for 96, right? That what is the value, what is the position in which 96 is in. And we do that by using our Tn, because as I said, this is still a sequence. Okay, so you're going to use the formula, which is Tn is equals to a n minus 1. So now we'll see our answer is 8. Now we've gotten our n, we now use the formula for Sn to get our answers. Now remember I said that we have two different formulas in which we use for geometric sequence. We have this one where you have r minus 1, while we have this one here where we have 1 minus r. And I said that we normally use this formula when r is greater than 1, and in this case here where r is less than 1. Now, it doesn't matter which one you use, you're still going to get the same answer, but it's easier to stick to the rule. So in this case, let's stick to that and use r is equals to, and this is the formula for where r is greater than 1. That's the one we're going to use, right? So we're just going to substitute everything we have here into that formula. So we're going to say it is S8 is equals to So putting that all in your calculator, you'll definitely get this as your answer. Now the second question over here says that the second term of a geometric sequence is 8, the 8th term is 1 over 8, calculate the sum of the first 8 terms. To be able to answer this question, the first thing you would need to do is also to try to write down a key. So I'm writing a key here to say that T2 gives us 8, we have T8 gives us 1 over 8. But this is not the key we need. We need things like A, we need things like R, we need things like N, and we need things like Sn for us to be able to get our answers. But looking at this one over here, we notice that we don't know what A is, we don't know what R is. This is 8, and also this is also 1. But this is the major question in which we need. So our goal here is to try to find out A and R. Whenever you have a question that you have two unknowns, the first choice you should always be trying to do is to get simultaneous equations. Simultaneous equations are used where you have two unknowns and it happens to be that you can get two equations to help you get your answers. And the first thing you see I wrote down was writing this stuff here, saying that T2 is equals to 8 and T8 is equals to 1 over 8. I would expand this out, right, by using the sequence formula for us to get two equations, and this is what I mean by that. Now we can represent this as equation 1 and we can represent this as equation 2. Now we are going to do simultaneous equation but use the elimination method, and from here I notice that if I can divide the second equation by the first equation, I'll be able to eliminate A, and that's literally what I'm going to do here. So I'm going to say the left hand side of the second equation divided by the left hand side of the first equation. So all I just need to do is just simplify. So as you can see, I've gotten the value for R, which is 1 over 2. For me to get A, I would need to now substitute this 1 over 2 back into any of the equation. I'm going to substitute into equation 1. So I'm going to say, now that we have A, which is 16, and we have R, which is 1 over 2, we can now finally get what our Sn is. So we can actually use the other formula, this one here. So now we substitute all this into our sum formula to see if we can get an answer. And this will be your final answer. That's it. Now example 3 here says the sum of the first 3 terms of a geometric sequence is 31, 1 over 2. The sum of the fourth, the fifth, the sixth of the same sequence is 315 over 16. Determine the value of R. So the first thing you need to do in this question, like we did in the previous one, is represent it, right? Represent it out in numbers as best as you could. We understand here that S3 is equals to 31, 1 over 2. Now they tell you something else. They tell you that T4 plus T5 plus T6 is equals to 315 over 16. S2 is gotten by saying T1 plus T2. That's what that is. It's the sum of the first 2 terms. So S3 is by saying T1 plus T2 plus T3. S6 is actually T1 plus T2 plus T3 plus T4 plus T5 plus T6. I notice over here that this T4 plus T5 plus T6 is the exact same thing that we have here. S3, as we said before, is T1 plus T2 plus T3. It's this whole thing that we have over here. So we could actually say by adding these 2 answers here, that will give you S6. So I could just say S6 is equals to 315 over 16 plus 31, 1 over 2. Now when you add these 2 together, that gives you 567 over 16. Now we already said S3. I like questions in improper fraction than mixed fraction, so I'm going to change that. So that there is 63 over 2. So just like when we have 2 unknowns, we don't know the A, we don't know the R, we have somewhat of the Sn. This is kind of given. A is unknown, R is unknown, and we have N to be 3 and 6. That's what we're working with. So again, 2 unknowns means simultaneous equation. Okay, so the next step we're going to do now is to expand this out. So now the next step is now to use simultaneous equation. So again, we have 2 equations. Now this looks weird, I understand. It looks difficult, but we do not change our approach. So remember what we did in the previous question, whereby we noticed by dividing one by the other, you can remove a letter. Now I notice that if I divide equation 1 by equation 2, I would be able to eliminate A, right? And that's what I'm going to try to emphasize. So I'm literally going to do that. I'm going to write 1 divided by 2. Now, you need to be careful while doing this because it's very easy to make a mistake. You divide the left-hand side first, then you divide the right-hand side first. 1 divided by 2 left-hand side, 1 divided by 2 right-hand side. So this is what I mean. The next step is to change division to multiplication. Then we can cross cancel. This will cancel that out. This gives you 8. Okay, so we're almost there. The next step is difference of 2 squares. Now this stuff over here, I'm going to rewrite this in a way that I can do difference of 2 squares, and this is what I mean. This can be written as 3 Now looking like this, we can now cross cancel again. This will cancel that out. So finally it's just simplification and you're almost home. So these are examples of exponential series and how they expect you to answer questions like this. And that's it. If you like the video, don't forget to give me a thumbs up and subscribe.